if you want. All right, here we go. We're doing boiling point elevation, freezing point depression for water. We do that, we need KB, which is 0.512 degrees C per mole, and we need KF, which is 1.86 degrees C per mole. These will be given to you on the test. We have the equation, the delta T of the B, meaning the boiling point, will be the KB times little m times I, which is the ionization constant, which is only for ionic compounds. And then the boiling point is going to be 100 plus delta TB, because this is boiling point elevation. So delta TF, so the freezing point change, is KF times little m times I. Again, ionization constant. However, the freezing point is going down. That's why it says, so 0 degrees C minus delta TF, or just negative delta TF, because if you're taking a number and subtracting it from 0, it's just negative that number. So, first things first, calculate the molality. Remember that molality is moles over kilograms of solvent. We talked about that right up here. So let's plug that in. First thing is, we need moles of glucose. We don't have moles of glucose. So let's go ahead and do that over here. 20 grams of C6H12O6, put that guy over 1. For every 180 grams of this, there's 1 mole. So 20 divided by 180 is 0.11111111. So 0.11 moles of our glucose. And then we have 2.2 liters of water. If you don't know, a liter of water is a kilogram of water. They are equivalent. So 0.2 kilograms of agua por favor. So 0.111111 divided by 0.2 is 0.5555. So let's just call that 0.56 little m glucose solution. Now, normally we would ask ourselves for I, because delta TB is KB times little m, which we just calculated, times I, and delta TF is KF times little m times I. However, this is an ionic compound. There are no ions in glucose. Glucose is sugar. It's a covalent compound. It does not ionize, and so therefore it does not have an ionization constant, so we just treat it as 1, so we can ignore it here. 0.512 degrees C per mole. We have 0.56 mole, and then we don't have I, so we don't have to worry about that. And then KF, 1.86 degrees C per mole. Again, same 0.56 mole, and again, I is 1, so we don't have to worry about that. So we take our little answer here, times 512 times 0.56 gives us a change of 29 degrees C, and then this change down here, 0.56 times 1.86 gives us a freezing point change of, that's divided by times 1.86. It gives us a freezing point change of 1.04 degrees C. So remember, the boiling point goes up. So 100 plus 0.29 degrees C. So that gives us 100.29 degrees C as our boiling point, and the freezing point is just negative delta TF, so that's going to be negative 1.04 degrees C. So that's how you do a boiling point elevation and freezing point depression for a non-ionic compound. So the next page here, we have an ionic compound. We have strontium chloride, so for that we need a dissociation equation. Strontium chloride right there, put an arrow, split up our ions here. Strontium, if you look it up on your periodic table, +2 charge. Chlorine, -1 charge. There's 2 of them, so that gives us 1, 2, 3 things. So that is I equals 3. It's not the charges, it's the number of things that are in the solution, and that's why ionic compounds need to have I in their formulas. So same thing with this problem as last problem. We do not have moles, so if we're going to calculate our molality of moles per kilogram, we need moles. So 95.8 grams of the strontium chloride And strontium's molar mass, I don't remember off the top of my head, so let's look here. It is 87.62, so we'll use 87. So 87.6 plus the 2 times 35.5 for the chlorines. So 158.6, and that's what our molar mass is, 0.6 grams for every 1 mole of strontium chloride. So now we can do it, 95.8 divided by 158.6. We get 0.6 moles. And again, we have liters of solution, so just like last problem, a liter is a kilogram, so we'll divide that by 1.5. Give us 0.4 molal. Pretty easy. So now we can do the Doyle to TB. Now we have B, little m, and I. We do have I this time since it's 3. And then down here, freezing point, delta TF equals KF, little m, I. So plugging these in, 0.512 degrees C per molal. We did 0.4 molal, and then we have 3 as our ionization. And for this one, we have 1.86 degrees C per molal, and then 0.4 molal, and then 3 for our ionization constant. So let's plug that into calculators, 0.4, so 0.512, and then 3. We get 0.62 degrees C, which means our boiling point goes up by that, so 100 plus that, and so that gives us 100.62 degrees C as our boiling point. So now we can take our same 0.4 and we're going to multiply that by 1.86, which is KF, multiply that by 3, and we get a freezing point change of 2.23 degrees C. And remember that the freezing point is just negative delta TF because it's 0 minus delta TF, so negative delta TF. So our freezing point is negative 2.23 degrees C. Colligative properties, super fun. Everybody has a good time. That's how you do it. Goodbye.